think I've told you guys this, that academics never really came easy to me. The only thing in the academic world that actually came easy was spelling. I've always been a good speller. Other than that, I've had to work real hard. Something else that comes very easy to me is sleeping.
Oh, me too.
How many people does sleeping come easy for? Right? I thought I could do it with my eyes closed.
Me too.
You like that build-up? That is, yes, it is. That is true, though. That is true. Spelling has always been easy for me. Everything else has been a struggle. Okay. So,
So sorry.
that's okay. Go ahead. Do what you got to do. Who wants to hear a pun about ghosts?
Me.
Who wants to hear a pun about ghosts? I need more than that. Who wants to hear a pun about ghosts?
Maybe they're not true.
That's the spirit. All right. My work here is done. Okay, let's take a look at the question. So you can see the scenario. We've got a ball rolling off a table. Table's 1 meter high. So we need to solve for both the original and final velocities in the x and y direction. What is the original velocity in the x direction? 2, yeah, because it's rolling at 2 meters per second. What is the final velocity in the x direction? 2. Why? Exactly. There's no horizontal force on this object, so 2 meters per second will remain for the entire time that this ball is in the air. Vertically, what is the original velocity? 0, because it's rolling horizontally off the table. So when we deal with that vertical equation, the original velocity will be nothing here. And of course, the final vertical velocity is something we'll have to calculate. Anybody get a number for that? That's okay. Let me just quick see what number I got, and then we'll go through it. I got... Yes. With no horizontal forces acting, that will remain the same the entire time. I got negative 4.43 meters per second for the vertical velocity that's final. So let's just figure that one out together. I want to find out what that velocity is going to be. I've got a couple options. What about this one? Will this work? No, because it's horizontal. Will this work? No, because it doesn't have final velocity in it. It's got original velocity. How about this one? This one solves for velocity. Can I use that? You could. It would be a longer process. You would need to get time, and you could get time using this equation. But we don't need a two-step process to solve this. I just want to use one step, and that's where this equation would come in. We know that our original vertical velocity is 0. It's rolling horizontally off a table. Then we've got 2. Acceleration is negative 9.8. And my change in height is going to be negative 1 because I'm going down 1 meter. So that would be my expression. Of course, to get rid of the square, we erase it. But if we erase the square, we got to take the square root of the other side. And once you do that, you're going to end up with your answer. Which is 4.43. Now, of course, this comes out of your calculator as a positive number, but remind me what goes on under the square root. Yeah, whenever you take a square root of something, the answer can be plus or minus. Because the vertical velocity is downward, this is a negative. Questions on that? Alrighty. If you haven't looked already in Schoology, your test, I apologize, is probably going to be on the same day that you have other tests next week, right before spring break. That's just kind of how things fell. And I don't want to we're near the end of this chapter, and I don't want you to go a week and a half and then forget everything. So we'll cram it in and take care of it. In terms of the homework, though, worksheet number 3. I'm guessing you want to go over the back side. Probably it's in its entirety. So why don't we do that, and then we'll just kind of pick and choose from the first side to see what you want to go over. How's that sound? All right. So on page number 2, the first problem, we've got a ball rolling down a ramp, and it goes through 2 photo gates there. Those photo gates are 30 centimeters apart. The end of the ramp is 92 centimeters above the ground, which just so happens to be the distance above the ground of our tables in this classroom. Where should a coin be placed so that the ball strikes it directly on impact? So if we're looking where a coin should be placed, what is the ultimate thing we're trying to solve for here? Distance, our horizontal distance. So x equals vt is the equation that we want. So in order to solve for that distance, we need velocity and we need time. So let's see here. It tells us that this ball takes 2 seconds to go through those 2 photo gates. I can use that information to figure out exactly how fast it's going, because velocity is distance over time. So I can figure out what this velocity is going to be. So my distance is 30 centimeters, and of course we want our numbers to be in meters. So as far as my velocity goes, my distance is 0.3 meters. The time is 0.2 seconds that it gives us. So that means the velocity is going to be 1.5. So I'm halfway to my solution. I know my horizontal velocity is 1.5. Next thing we got to find is t, and we can figure out what that time is because it tells us that the ramp is 92 centimeters above the ground. And because this is rolling horizontally, we can treat this problem as a free fall problem, basically. So the equation that I'd want to use to figure out how long it takes for the object to hit the ground, would I use this one? No, because there's no time there. Would I use this one? You could. You could use it because you could find this final velocity if you use this equation. And you could plug that in there, and you've got everything else to solve for time. That would be the 2-step way to do this. There is a 1-step way, though, and that would be our green y equation right here. Of course, the final height is 0 because it hits the ground. Original height is 92 centimeters, which would be 0.92 meters. My original velocity, what's this going to be? 0, yes, because this object is rolling horizontally off the table. It is not going vertically down or vertically up at all when it reaches the edge. So my original vertical velocity is nothing. This is a vertical equation, so the vertical velocity is what we would use there. And we've got 1/2 at squared. And we can use this equation in order to solve for time then. If I shift 0.92 over to the other side, it becomes negative. But then that negative is going to cancel out with this negative. 1/2 times 9.8 is 4.9. And then to solve for your time, you divide both sides by 4.9. And of course, in order to get rid of that square, we erase it. But if we erase the square, we got to take the square root of the other side. And that gives us a time of 0.433 seconds. That's a lot of work. Usually, we're given at least one of these numbers. For this problem, we had to figure them both out, though. So this was a bit of a drag. So the time goes right there, velocity goes in there, multiply them together, and you'll get your final distance equal to 0.65 meters. Questions on this one? Okay. Number 6 is the same thing. We're just going to change a few things about it. Number 6 is actually not too bad by comparison. At least we got that going for us. So now it's the same ramp, but now we know that it hits 25 centimeters from the end of the ramp. So our horizontal distance is 25 centimeters, which is 0.25 meters. Letter A, what was the ball's horizontal velocity? Well, if I'm going to solve for horizontal velocity, I got to go to my horizontal equation. So if x equals vt, that means v is equal to x over t. And we're given the distance. That's 25 centimeters, which is 0.25 meters. And as far as the time goes, any idea what I would use for my time there? So for the time on this one, we already figured out what the time was in the previous example. In number 6, we're traveling at a different horizontal speed, but we're still rolling off the same horizontal table. So no matter what, it's going to take the same amount of time for that object to hit the ground as in example number 5. So we can use that exact same time as long as the table is the same height, which it is. And that time was 0.433. And that gives us a velocity of 0.577. Letter B, how long did it take for the ball to pass through the photo gates? When it passes through the photo gates, is it doing something horizontal or vertical?
Just kidding, I don't know.
That's fine. Horizontal, because when it goes through the photo gates, it's going on the horizontal portion of that table there. So what that means, bless you, is that we got to use a horizontal equation. And that horizontal equation is going to be x equals vt again, because that's the only horizontal equation we've got up here. Now, if we're solving for time, that means it's going to be equal to distance over velocity. And it gives us the distance, that's 25 centimeters, in other words, 0.25 meters. And the velocity, let's see here, we found in letter A. That velocity was 0.577. So when you do that math, you'll get the amount of time. Should be 0.52. So that's 6. That one's not as bad. Now let's get on to the real bad ones, number 7 and number 8. These are the challenge problems, so we'll work through these together. We'll do this the short way that I taught you as opposed to the long way. For reference, if you looked at the answer key on this, the long way is what's given on the answer key, because when I made these, I did not have a smartphone, like most people didn't have smartphones back then. So I also still never really used a graphing calculator too much, so I had to use this guy, and without the quadratic, I just did it the long way. So you can ignore, if you looked at the answer key, the way to solve this. I'll show you the short way right now. The answers should still be the same, though, and the first step is going to be the same for both. So 7, we have to figure out the range of the sphere, and what it's asking for there is the distance than it is from where it leaves the ramp. So we're looking for x. Now, the first step for these problems where something is being launched at an angle is to figure out the components of your velocity. So it says it's moving at 3 meters per second. And it's moving at an angle of 20 degrees. So you basically treat this just like a triangle. You need to find your velocity in the x direction, and you need to find your velocity in the y direction. It doesn't matter if you label the x direction with just an x or an xo, because it doesn't change. It's going to stay the same the whole time, as we mentioned. So you just got to solve for these sides of the triangle then. So if I'm going to solve for the adjacent side, I have to use cosine. So cosine of 20 is equal to adjacent over hypotenuse. Therefore, 3 times the cosine of 20 degrees is what you have to do. When you do that, you get 2.82. You would do this same process for the vertical component of that velocity. The only difference is you'll have a sine in here instead of a cosine. And of course, you'll get a different number. Everybody on board with this procedure so far? Solving for triangles. Okay, so that's step 1. Step 2 is going to go in a different color. What color should we use? Red is good. Okay. So now that we have these velocities, if I want to solve for the horizontal distance, I need velocity and I need time. I have my velocity now. My velocity in the x direction is 2.82. So I got to get my time. I'm not going to use this equation because there's no time there. I'm not going to use this equation because I don't know what my final vertical velocity is. And that leaves the little green guy there again. So let's use that equation, see if we can get a time. Final height is, of course, 0 because it hits the ground. Original height is given, that is 1.2 meters. Then we've got original velocity times time. What original velocity goes here? We've got a lot of velocities. We've got 3, we've got 2.82, we've got 1.03. Which one goes in right there? 1.03, because this is our vertical velocity. Therefore, it has to go in the vertical equation. And then we've got 1/2 at squared. 1/2 times negative 9.8 is negative 4.9. Then you've got t squared. And there's your friendly neighborhood quadratic. Negative 4.9 is your A. 1.03 is your B. 1.2 is your C. So you just go ahead and plug that in, which I'm going to do. I ended up with a time of 0.611. You get 2 answers, a positive and a negative. You should always pick the positive answer for these, The opposite answer would be the time as if instead of being launched up, it was launched down, which is why in this example, if you do it, you get a smaller number. That would be 0.4. So yeah, 0.611 would be your time. So you've got time, you've got your horizontal speed, and you can then calculate your horizontal distance. I got 1.72. Which hopefully matches the answer sheet. Yep. One quick thing to take note of in this whole procedure, that 3 meters per second, this goes nowhere. It goes in no equation after you calculate your velocities. It does not go in for this velocity. It does not go in for this velocity. It is nowhere to be found in your equations. All of these equations are either vertical or horizontal, and so your velocities have to be treated that way. Questions on number 7? Okay, we'll do number 8 too then. We'll kind of go quickly through that because it's basically the same example, except now it's going down instead of up.
What time is this class on?
10:08, I believe. Yes. Yeah, 10:08. Okay, so we'll do number 8. And we'll go through this one a little bit faster. So it's the same example. We're going at 3 meters per second again, but now instead of launching up at a 20-degree angle, we are launching down at a 15-degree angle. So let's set that up. So this is kind of our setup here. We're launching down at a 15-degree angle, and of course step 1 in this process is to figure out what that velocity is in the y direction and the x direction. So we solve for those the same way we solved for them before. In the x direction, we got to use cosine because it's the adjacent side of the 15 degrees. In the y direction, we got to use sine. So let's see, in the x direction, that comes out to 2.9. In the y direction, that's going to come out to 0.776. And because we're going down here, it's going to be a negative 0.776. So that's our starting point. So we've got our horizontal speed. That's going to go here. Now we've got to solve for time. And we'll do that the same way we solved for it before. We use this y equation. Final height is 0. Original height, that is going to be 0.9 in this case. Original velocity in the y direction, that is negative 0.776. And then 1/2 at squared looks very familiar. It'll always be that value as long as you're on Earth. Bless you. You do need to make sure that when you're plugging this into the quadratic that you are including the negatives where appropriate. So for your A, that's negative 4.9. For letter B, that's negative 0.776. So when I do this on my little quadratic app, I get my two answers. The positive answer is 0.357. So I know that's going to be the answer because it's positive. As we would expect, the negative number is greater because that number would be if we launched up at a 15-degree angle. So 0.357 is our time. And to finish this off then, it's velocity times time. For the horizontal equation, we put in the horizontal velocity, which is 2.9. For the time, we put in our 0.357. And let's see what that comes out to. I got 1.04, which matches the answer sheet. That's always a good thing. So that's how the difficult problems go. What's that? There'll be something like this on the test, yeah. One thing that you need to be aware of in physics is there's a lot of partial credit to go around. So it's not like if you get it wrong, you lose all the points. If you do step 1, you get a point. If you do step 2, you get a point. If you do step 3, you get a point. So
if you were to get like the first one wrong, but you like did the work right and you continued with that same answer, would you mark off for it being wrong?
no, I mean, you just lose points for that one. If you do everything subsequently correct, you'll get credit for that. I thought we got out at 10:08. Am I wrong?
I can pull up the...
Oh, we're still in class. That's the bell for the preview to end. Yeah, we're still here. Okay. So let's do something from the front side. Any preference on what we go through with the remaining time? Once. Going twice. Otherwise, I'll just pick.
Wait, I have a quick question.
Yeah.
Never mind.
Okay. Let's do, let's go ahead and do number 3. Number 3. I wrote this one about a childhood friend of mine, actually Alex. He lived across the road from my brother and I. And occasionally our parents would take us to Red Granite Quarry, which is in the little city of Red Granite. And it's a really fun place to swim in. And so that's...
Because, like, they weren't allowed there anymore. Like, this one. And, like,
Who?
the jumping.
Oh, you know about that? That's a long ways away.
Yeah.
Okay. Yeah. Yeah, they had to, like, cut down some of the areas where people were jumping because they were too high. So they redid a lot of it. It looks really nice. It's still a fun place to go, but you can't jump off as high anymore, which is a little disappointing, but it's still fun.
The police came and shut them down.
Yeah. How do you know about this? Do you go up there?
Well, I was going to, but then my friends were like, oh no, like the police said no.
Oh, okay. 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 So we'll go through this together, and it shouldn't take more than a couple minutes. So here's what we know. Alex is running off the cliff at Red Granite Quarry at 3 meters per second. He's falling like this. So he's going at 3 meters per second here. There we go. And we know that he lands 4.5 meters from the cliff edge. So the question is, how tall is the ledge? And yeah, that's it. So if we want to figure out how tall the ledge is here, I would probably go to this equation. And you've really got two options for this problem. You could also go here. You'd have to calculate that final velocity first. And you could do that using this equation. But you'd need to get the time. Yeah. So it's kind of a horse apiece here. Let's start with this guy. In order to figure out that height, we know the final height is going to be 0. Original height is what we're looking for. Original velocity is going to be 0 because vertically he is not going anywhere originally. So that's 0. 1/2 AT squared. 1/2 times negative 9.8 is negative 4.9. So if I want to solve for the height, it's going to be 4.9 t squared. Because if I move this over, and that's the first bell, that's not ours yet again. We've got 2 minutes. So, yeah, that cancels out the negative when I shift this over. So I got to put time in, but I don't know my time. But I can find it because I know the velocity and I know the distance. It's pretty rare that we use this equation to find time, but we can do that here. Because we know the distance and we know the velocity. Therefore, our time is 1.5 seconds, and that is what we toss in right there. So 1.5 squared times 4.9 is equal to 11, and that then is how tall the cliff at Red Granite Quarry is. Which is about as tall as some of the cliffs they have there. I don't know how big they are now that they've cut them down a little bit. That's about how high you jump from.
Please pardon the interruption. At 10:08, the second floor first hour classes should be dismissed to the WOFAC.
Leave your homework on the table. I'll collect that.
First hour classes should be dismissed to the WOFAC at the bell. All other students should be in their first hour classroom.